Okay, in this video we're going to talk about the definition of continuity. Okay, so the definition of continuity, it has 3 steps. The first step, f of a must exist. Okay, so it means there must be a solid point. Okay, the limit as x approaches a of f of x must exist. Okay, so that means the left-hand limit has to equal the right-hand limit. Okay, and the third step of continuity is f of a equals the limit as x approaches a of f of x. Okay, so pretty much what continuity means, or continuous function means, that there's no holes in the graph, there's no breaks in the graph, there's no jumps in the graph. Okay, so what we're going to do is we're going to do it using the definition and these piecewise functions, and we're going to go through and graph them. Okay, so usually when we prove continuity, it's going to be at whatever x values over here. So we're going to prove it at x is equal to 1. Okay, so we're going to go through our 3 steps. First step, f of 1 must exist. So f of 1 is going to be in this branch. So I'm going to plug in a 1. 1 minus 4 is equal to a negative 3. Now I'm going to do the limit from both sides. So I'm going to do the limit as x approaches 1 from the negative side, and the limit as x approaches 1 from the positive side. Okay, the less than branch is always going to be the negative side. Okay, so I already plugged in a 1 up there, I get a negative 3. Plug in a 1 on the bottom, I get 3. Okay, so the limit does not exist. Does not exist, therefore not continuous at x is equal to 1. Okay, and that's how we prove continuity. There's no such reason to go to the third step, because the second step is violated. Okay, so if we're going to graph this, we're going to get x minus 4, and we're going to make a little t-chart. Okay, so we're going to start at 1. We're going to pick values less than 1, like that. So plug in a 1. 1 minus 4 is a negative 3, negative 4, negative 5, negative 6, and negative 7. Okay, and then the line y is equal to 3x. I'm going to make my t-chart for that. Okay, so I'm going to start at 1. So we get a 3, 2, 6, 3, 9, 4, 12. Now, like we did before, this is going to be closed in this branch because of the equal to, and then it's going to be open in this branch because it's not equal to. Okay, so let's go graph this. So the point 1, negative 3, 1, 2, 3 is going to be closed. 0, negative 4. So it looks something like that. And then the point 1, 3. 1, 2, 3 is up here. And then it's going to go up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. So it'll look something like that. Okay, so we can see there's a big jump in the graph, and it makes sense because the limit does not exist. If we were coming from both sides, in order for the limit to exist, my fingers would have to meet up. Okay. Okay, cool. Next example, step 1. So we're going to prove it at x is equal to 0. So f of 0. Okay, we're going to be in the equal to branch, is going to be 4. Okay, 0 plus 4 is 4. Step 2, we're going to prove that the limit exists. So we're going to go the limit as 0 from the left-hand side, and the limit as x approaches 0 from the positive side. Okay, as I come from the left side, my limit is equal to 4. We already did that one. Remember, the less than branch is the minus branch. Okay, as I come from the right-hand side, it's the greater than branch, so plug in a 0. 0 plus 4 is going to be 4. So that means that the limit as x approaches 0 of f of x is equal to 4, just like we did before. Okay, so step 3. Since step 1 is equal to step 2, then it's continuous. So we got to write it in math terms. So we're going to say f of 0 is equal to the limit as x approaches 0 of f of x, therefore continuous at x is equal to 0. Okay? So there shouldn't be a jump in the graph. Okay? Now let's go make our little t-charts and let's confirm it graphically. X plus 4, and then I'll do 2x plus 4 over here. That. So I'm going to start at 0, 1, negative 1, negative 2, negative 3, and negative 4. So plug in a 0. You get 4, 3, 2, 1, and 0. And it's going to be closed because we were in the equal to branch. Okay, I'm going to start at 0 over here, and I'm going to go greater than 0. And I'm going to be plugging in here, so we get 4, 6, 8, and then 10, and 12, like that. And this is going to be open because there's no equal to sign right there. Okay, so when we go to graph this, the point 0, 4, 1, 2, 3, 4, like that. 1, 3. Looks like that. Okay, and then 0, 4, and then 1, 6. 2 over 1, 2 over 1, 2. So it looks like that. Now, one point that this brings up is just because something's open, once it becomes defined at that point, it stays closed, okay? They don't undo each other. So in this case, it's closed here and open here, so it remains closed, okay? So once it's closed, it's closed. They both possibly could be open, and you won't get, you'd have a hole in the graph, okay? So on to the back page. So these are examples like what we just did before. F of 1 is defined in the top branch, so we're going to do 3 times 1 minus 2 is equal to 1. 0 is defined in the top branch. Okay, so 0 minus 2 is equal to a negative 2. Remember, 0 times 3 is 0. Plug in a negative 1. Negative 1 is defined in the top branch. So we get negative 5. 6 is defined in the bottom branch. Okay, so 6 plus 2 is going to be 8. Now I want to find the limit as x approaches 1. Okay, so we have to do our left-hand limit and the right-hand limit. So the limit as x approaches 1 from the minus side, and the limit as x approaches 1 from the positive side. Okay, so from the minus side is going to be the less than branch, so I'm going to plug in a 1. 3 times 1 is 3 minus 2 gives you a 1. If I plug a 1 into the bottom branch, I get a 3. The limit as x approaches 1 of f of x does not exist. Okay, remember the left-hand limit has to equal the right-hand limit for the limit to exist. Now I'm going to prove the continuity of the function at x is equal to 1. So I'm going to go through the 3 steps that we learned earlier. So step 1, f of 1 is equal to, we said, was 1. Step 2, the limit as x approaches 1 of f of x does not exist. Okay, because we just did that up there. Therefore, not continuous. X is equal to 1. Okay, so therefore is the 3 dots. I don't know if you've ever seen that before. Okay, so we didn't have to go through the third step because the second step was violated. Okay, so that's been continuity notes set number 1. Hopefully this made some sort of sense to you. Thanks, and have a good night.